My name is Maeve. I'm a reporter at Latitude Media. I'm really excited for this conversation. I hope people are trickling in with their happy hour drinks in hand. We're going to talk about a huge topic, grid modernization, but instead of thinking about this from a new construction, new build perspective, we're going to talk specifically about optimization. And all of the panelists today are experts on that. I'm going to briefly introduce them, and I know you guys will talk more about your work throughout. Morgan, who is a familiar face to everybody at SF Climate Week, is co-founder and COO of Grid IQ. Julia is executive director of the Watt Coalition and also director of policy and strategy at Grid Strategies. And I'm just following you around this week. I've seen you at least 3 other events. And Brian, last but not least, senior director at Advanced Energy United. Great to have you all here. We've got 45 minutes. We're going to leave about 10 minutes at the end for audience Q&A. But the conversation is really around maximizing the grid that we have. And I've seen the conversation about this on LinkedIn. I think people are calling it grid maxing, which maybe Julia, you coined, which is very fun. I like that. But essentially, we're talking about sensors, software, even policy approaches that can make better use of the grid that we have. So to start, I think I want to just level set a little bit about the technologies that we're talking about here. And Julia, forgive me, because I know you've already given the pitch on this earlier today, but I want to start at a transmission level. What are the tools, the core technologies we're talking about here when it comes to grid enhancing tech?
Hi, everyone. Oh, loud. Hi, really great to be here and closing out the day. So grid enhancing technologies, the main takeaway I hope everyone has is that there is a bunch of latent capacity on the grid that if we use relatively new, invented in the last 20 years, technology, we can actually access that capacity and use it. So the technologies I represent are threefold. The first is dynamic line ratings, sensors and software that use weather forecasts and weather data to determine how much capacity a transmission line has, usually finding about 20% more on average than the utility's assumptions for that line. Another technology is advanced power flow control. This sits at a substation and can push and pull power off of overloaded lines onto lines with capacity. So PG&E has a great project in the works where they have found 100 megawatts of additional grid capacity in the San Jose area just by redirecting power flow, which is really exciting, one of the flagship projects in the US in our backyard. And then the last technology is topology optimization. And this is software that is like a Google Maps or a Waze for the grid. It says, okay, you have this generation and you have this load and you have this transmission system. As you flip switches across the grid, you can redirect power for free, essentially, no new device at the substation, and deliver way more clean energy, potentially, over your existing grid. So those are the grid enhancing technologies categories. There's more in the advanced transmission technology category, like high performance conductors, new wires that can carry twice as much capacity and are stronger and lighter than traditional wires. So that's part of the advanced transmission technologies category.
And we'll just pass it over to Morgan to chat a little bit about what Grid IQ is doing and to also maybe give us a walkthrough of what these technologies look like on the distribution grid.
Awesome. So Grid IQ is falling into that sensor category where the technology that we have sits on the distribution line. It emits a low energy signal that comes back with a lot of data about what's happening on the line itself. And so we operate in the medium voltage space. It's a little bit trickier than transmission. There's a lot of different types of hardware and configurations. The lines can be very different. And so we've developed an ML model that takes a lot of those different types of inputs and things that really impact how those readings will actually appear. And through machine learning and through AI, we've built a detection algorithm that can help remove what is noise in that data and what are the actual peaks and troughs that are worth listening to. And so that's how we operate. The core raison d'etre for the company is to prevent forest fires, but really it's good for anything around early fault detection and fault location, which is also an interesting issue because currently, a utility might know where the fault is, that there is a fault, but it can be very hard to know where exactly on the line that fault exists.
Perfect. And Brian, over to you for our biggest picture question, really from kind of a grid orchestration and a market design perspective. What does it mean to be making the most out of our grid today in a load growth era, in an era where we're talking a lot about affordability for ratepayers, and there's kind of all of these tensions playing out at once?
Okay, that's a great question. Thank you for it. Thank you for inviting me to be here. I'm glad to be here. So Advanced Energy United, we represent a bunch of companies across the advanced energy spectrum, including grid enhancing technologies and advanced conductors, but I won't talk about that because Julia can run circles around me on that. I'm going to talk about the distribution system, especially like what Morgan was talking about. 3 reasons we're doing this, right? Build it, make it flexible, make it affordable. Building it, electrification is coming. We need to have the grid ready to connect all those loads. A major problem in this state right now and across the country, EV charging stations not able to get connected. New housing developments, we just heard about that, not able to be connected. And the way the utilities respond to those requests, historically, because they had low load growth environment, they did it incrementally, piece by piece. When you're talking about the load growth that we are experiencing now, even just with that end-use electrification and housing, not talking about data centers, that's the most expensive way you can do it. So how can we allow for building, making it flexible so that all the resources that we've got on the distribution system, all those electrified end uses, which have tremendous flexibility built in, can be utilized as a grid resource, and then make it affordable. Not only are you reducing the number of wires and substations that you're building ultimately, but you're also moving more power through the existing wires, which brings down rates, creates downward rate pressure, let's say, for all concerned. So that's what we're trying to do. And then what's the concern with grid modernization, or what's the objective with grid modernization now to realize those objectives? A great lesson is from what we called grid modernization 20 years ago, which was the first generation of advanced metering infrastructure rollout, AMI 1.0. We rolled out a bunch of technology that had incredible data granularity and capability, of which we used 10% of that capability perhaps, because there was perhaps inadequate planning for the systems to make use of those data. So now with AMI 2.0, with DERMS rollout, ADMS, all the VPPs, storage on the transmission and distribution system, incredible resources that we've got on the distribution system. We kind of really need the framework that ties them together and makes them into a usable resource, not just a collection of technologies that we then on the back end have to figure out how to piece together.
Okay, perfect intro. When we were talking about how to frame this panel, something that came up was one of the Department of Energy liftoff reports on innovative grid deployment, I think was the title. And this was a report that was published in 2024. And they looked at kind of solutions across what you have just laid out at the transmission level, at the distribution level. And they found that deploying these technologies at scale would drastically increase existing grid capacity and save a lot of money. I don't know the exact numbers, I'm sure that you guys do, but that deployment was lagging. And this was back in 2024. But the agency laid out these 4 pillars of success for getting these technologies off the ground. And I thought that it could be interesting to have you guys kind of run through those 4 pillars, give a little grade, how are we doing on each of those for the technologies that you're really focusing on. So the 4 priorities from DOE were: 1, build up a bank of evidence of the technology's value proposition. 2, develop the know-how for using and deploying them across grid operators. 3, refine the pitch on benefits and costs. And last but not least, align economic models and incentives. So a small list, easy things to do. Where are we at, Morgan, when it comes to line monitoring, grid visibility controls at the distribution level?
Well, I definitely won't claim to be a market expert at this stage, but I can speak to some of the challenges and opportunities that we see at Grid IQ. I think one of the biggest things is that the technology we're looking to develop is more complicated than what a lot of people are doing in San Francisco. Like, we need access to a medium we call it medium voltage in the system, but really it's high voltage to anybody else, like 12,000 kilovolts. Like we're talking about a lot of power here. And so it's difficult to just find a testing facility and be able to like start gathering data. And so building those partnerships, building those avenues for how those partnerships can take place, and more people can get into the space and be working on these types of product developments, I think is a big one. And I'll pass it to you guys to talk more about the market perspective.
Yeah, I remember reading that report and being really excited about a lot of the results. And with the pillars, I think a lot of technologies were covered under there, and everyone was put into this pillar. And like pillar one was develop the case studies. I was like, grid enhancing technologies already has those case studies. A lot of them are from other countries because they're moving faster, but we have the case studies, check. And then the next piece was we need like 12 at-scale deployments in 3 to 5 years. I was like, oh, do not make me wait 5 years for this. I hope it's faster. And I think it is faster. Like that PG&E project, there's a version of it happening in Georgia Power in Georgia. There's a project in New York. There's a project in Vermont, and that's just advanced power flow control. So I think we've moved faster in those flagship deployments. And then the last piece of the equation was, can we align incentives? And I'll say the closest we've gotten to that is the AI boom, right? Now there's a real reason for utilities to interconnect or to move as fast and potentially as cheaply, but certainly as fast as possible to get these new loads plugged in so that they can sell them electricity for the next 100 years. So that has helped, but other than that, there's not really that fundamental driver for these technologies. The pattern we see when a project like this comes through is that there is a champion at the utility who sees the best way to solve a problem in front of him or her, and is prepared to like put their reputation on the line to push it forward and make enemies and fight through a lot of no's. And that does not scale very well. So we're definitely still looking for that kind of systematic change. But the last piece of the puzzle.
So I remember the 4 pillars as well, and I think we're doing pretty well on the first 2, right? Getting the case studies, getting the operations experience. And in California, certainly we've pursued a pilots first model that has done pretty well at gaining that experience. Turning that into a cost effectiveness framework works to some extent for those individual one-off case studies that then can be translated into a similar project in a similar utility. However, is that the right approach for taking for some of these grid modernization really platform opportunity? The technologies that we're looking at should be something that is more consistent across utilities so that the ecosystem of technologies that interact with them can interact with a consistent framework and not one-offs per utility that require individual API integrations for each utility. And one of the reasons for this is a critique of the DOE report. They talk about the definition for grid modernization technologies ending at the customer meter. It's all front of the meter. What are those, especially on the distribution side, what are they interacting with? All the devices on the customer side of the meter or at the meter. Right out there, we've got a SPAN panel. SPAN panel is an incredibly intelligent, flexible device that can do a lot of load management and a lot of other grid services for the grid. It's on the customer side of the meter, but it should be interacting with the modernized distribution grid. And for that, we need a consistent framework that can interact with a bunch of these technologies, allow for technology development. Many of you are representing companies in this space. You know what a dynamic environment it is for creating these technologies. One-off implementations by utilities of individual technologies, as successful and diligent some of them have been, even for those leaders, I think is a little limiting to the kind of evolution that we're capable of right now.
I think you've teed up my next question before we talk a little about case studies, which is whose responsibility is it from a regulation and policy perspective to get these technologies deployed? Where should people be focusing their efforts, their energy? Where should they be looking?
Yeah, it feels like that's another area that's not as standardized as well. And so there's some really interesting examples of projects that have gotten off the ground with like a coalition of members that sometimes include the utility. I know that there's an interesting case with PG&E and getting a great like microgrid set up and having to go to CPUC and work on like that funding model. And it took a couple of years to kind of like pull all of the resources together with a few different advocacy partners to make that happen. There's other models, I think, where like there's grant funding that might be available, but then sometimes gets pulled back. We're working with a microgrid in Humboldt that's looking at an enhancement to their microgrid in terms of how they connect to the utility, and they're looking to implement Grid IQ to be able to, after a power shutoff, prove that there are no faults on the line so that they can re-energize faster. Oftentimes that takes a manual check where somebody comes out to prove that there is no fault before re-energizing, and so that just takes time. And so they had funding from the federal government to support a project like that, but that funding got pulled and now the project is stalled. And so I think kind of when we think about like standardizing some of these things and how, like what actually scales, being able to know like what are the different avenues and who are the actors that need to come together to get something financed, and does it always need to be a rate case, or are there other, what are the other kind of channels for that? I think being able to like lay out several options that fit the right type of project and the timeline for that project would probably be really helpful in terms of being able to get more people knowing here's how to access the resources and the capital that's required.
A central problem is how siloed the utility itself is, the responsibilities within the utility, and then the regulatory side is also pretty siloed. Like the transmission grid economic regulator is the Federal Energy Regulatory Commission. A lot of the reliability standards are set by the National Electric Reliability Corporation, North American Electric Reliability Corporation. The states have authority over transmission siting and resource planning. So it ends up being a little bit of a game of ping pong, both at the regulatory level and then within the utility. Whose responsibility is transmission line rating? Sometimes it's like the asset manager, a role that people probably haven't even heard of. It's where does the buck stop? And the answer we've come across is you kind of have to push on all fronts to see change, which doesn't always feel super efficient. And I think some utilities are leading in trying to create more of a pathway from pilot to deployment or from commercialized technology to deployment. That's one thing the grid enhancing technologies companies go crazy over is we've done 10 pilots. Do I have to pilot with all 3,000 utilities before they agree to use my technology? That shouldn't be the case, right? So I think PG&E is one of the utilities that is actually kind of has a central grid innovation team that's working on smoothing that pathway. Sorry, I just keep talking about PG&E, but some good examples in our neighborhood, which is great.
Building off of something you said, which is the disconnect between the silos. I think one of our biggest issues is the disconnect between operations, planning, and then regulatory. And actually somewhere in that operations and planning, you have to throw in the utility capital allocation process as well. Where are they putting their money? Operations people increasingly, thanks to the pilots and the successful projects we've talked about, know about these technologies and what they can do for the system. Do they get them to the people that are arguing over the capital allocation budget? Do they get them to the planners who can use them in the planning timeframe? In the distribution planning context, we're talking about technologies that can utilize the flexibility at homes and businesses already out there and coming to reduce the need for new distribution wires and transformers. That isn't how it works in the planning context. Even the load forecast in California, it comes from on high at the CEC, and they are peanut buttering a load forecast across the state. It does not accommodate for that business down the street has a flexible interconnection and can actually turn down its demand between 5 and 9. Or I've got a bunch of people on a VPP that will do so en masse on a distribution circuit. And so therefore we can build less lines, let alone that the people, the operations that have the operations with the DERMs can translate a business case for how to utilize those DERs into investing in a VPP program. So there is some improvement being made there, and I think that a policy can make a big improvement in that, because we're, for instance, in California, we're extending that distribution system planning timeframe a little bit longer, so it's not all reactive all the time. It's a little bit forward-looking. And you can put mandates or incentives on the utility to integrate flexibility into that planning. I look at the UK, which is not a perfect model in any means, but they do use an incentive-based compensation that says, you're the distribution system operator, you can build wires and poles, or you can invest in DER flexibility. You have to invest in DER flexibility first before you can make the case you're going to invest in wires and poles. And in fact, if you invest in more flexibility, we'll give you more return on the total expenditures that you're spending, your TOTEX, which is a better rate of return or better way to incentivize spending than CapEx, which is the current utilities bias. So that's probably enough.
Yeah, if I can just double down on the UK model, the UK has overhauled its electricity regulation 2 or 3 times in the last 15 years, and they haven't broken it. In fact, I think they've gotten some really good results. So we should definitely learn from them, including an incentive they put in where if a utility could find a cheaper way than the baseline to solve a constraint or solve a problem, the utility got to keep, I think, half of the savings. That's potentially, we're talking about hundreds of millions of dollars of infrastructure, and the regulator is saying, look, you do it cheaper, you get to keep half of that, and the rest goes to the customers. Pretty good deal for everyone. And they said, yep, we're going to install 2 types of GETs, maybe even 3, and unlock in total more than 3 gigawatts of transfer capacity, save hundreds of millions of dollars. Everyone's happy. So kind of magic how well that worked.
I'll actually pass this back to you, Morgan, because I want to double down on the Humboldt example that you mentioned earlier. Talk to us a little bit about kind of how that came together, how it's being financed, and whether that is replicable. Like, how are you thinking about that example for future Grid IQ deployments?
I wish I could for the Humboldt microgrid financing. It actually, it was through the Schatz Energy Center, but they actually had the federal funding secured before we connected with them. And this was going to be like an addition to the project that they already had as part of like their interconnection. And then it's stalled since then. So instead, the creativity's been on the backside. It's been like, how can we together align our incentives so that the project can still move forward? And so for Grid IQ, we're an early stage company. We want more real-time deployments, so we're going to do our work pro bono. And use this as a great opportunity for us to collect more data on the grid. And on their side, they're also looking at how do they pull some of the resources together and kind of align that to be able to make this work. It's kind of similar to like how we're doing our first high voltage testing. So like we're working with Idaho National Labs this summer. They have a wildfire utility research project that they have that's unfolding later on this fall. And when we came to them with the sensor technology that we had and talked about our needs in terms of getting access to a high voltage testing facility, they said, well, actually, the data you're collecting is be really useful, and it's more interesting than the sensors that we have for the project later on this fall. Why don't we bring you guys into this project and we can pull it under the funding that we already have allocated? And so it's been a lot of like aligning incentives of, you know, what can we do? What can other folks do? Where does the funding already exist? And how do we tack on to projects that are already in flight?
And go ahead.
I just wanted to play on that to make one factual statement, which is, you know, the largest growing share of your electricity bill, the revenue requirement for the utilities, transmission, distribution, and wildfire spending. They are the huge cost drivers in the state right now, and that's where grid modernization has its greatest opportunity to reduce, but it's also where we're facing the biggest disconnect between the current incentive structure, capital bias of utilities, and performance-based incentives, where we have the greatest need for more performance-based incentives. Grid-enhancing technologies reduce the cost of transmission, grid modernization on distribution, the kind of sensing infrastructure that you're talking about on wildfire spending rather than undergrounding. Anyway, they're most cost-effective options, but the current incentive structure and capital bias is one of the biggest barriers.
just add on to that too. And that's such a good example too of where like the CapEx problem and also the like utility rate case problem is an issue, because a lot of this money's been allocated for several years in the future. So a new technology can come along and it's like, this would be a much more affordable way of using old infrastructure without having to replace something or underground something. But like the operational model that would make the most sense for Grid IQ is actually like MRR. Like we have a hardware device. Our hardware device, like compared to most things the utility buys, is just not that expensive. What's expensive is the ML models and the AI that we're running that's monitoring things in real time. And that is really more of like a monthly like subscription model that would be a better pricing for us. But we're already looking at how do we change how we're gonna do our go-to-market pricing so that we fit better into the CapEx model. But that's kind of a perversion of the right way of designing this, right? And so we're forced to do that, and that's something we're already thinking about, but it would be great if we were able to price this the way that actually matched the utilities incentives.
Okay, I have one last funding question for you all. To loop this back to DOE, I'm sure you all saw that some of the GRIP funding, grid reliability funding, from late 2024 was reinstated or maintained. I think that was last week. And then simultaneously, DOE is also starting to release this kind of rebranded version of that funding called Spark. So my question is, one, how are you all thinking about that? And how are you thinking more broadly about the role of the federal government as a partner and potentially an investor in this space?
Oh, last since I went.
Sure. Yeah, it's a huge amount of money, right? That is going to subsidize innovation and de-risk innovation for the ratepayer and for the utility. And so I think it's really exciting. It's amazing that the through line in one of the biggest political pendulum swings of my lifetime, certainly, that transmission and grid modernization has kind of continued its momentum through that. And it speaks to the needs of the country, really. Like the transmission grid is the backbone of the American economy. So the Grid Resilience and Innovation Partnerships Program, the GRIP funding, the major GETS projects, many of those were continued. That's exciting. And then the Spark funding, $1.9 billion in matching funds, all targeting grid enhancing technologies and high performance conductors. I think we'll see maybe 100 different grid modernization projects out of that are at really significant scale. So I'm just stoked out of my mind, as they say.
Earlier, we talked about the 4 pillars that DOE put out and how just experience with case studies and operational experience are going to make a huge difference. And I think that funding goes to those 2 first pillars. And the utility industry is a small c conservative industry. It has been doing things the way it has for decades. They've kept the lights on, and that's fantastic. And they need experience with new technologies in a wide variety of contexts, co-ops, munis, IOUs across the country, large and small, and then they get together within the industry venues to develop the best practices to make use of those. That's a bottom-up approach to the kind of consistency that I was describing earlier. It perhaps is a slower and more haphazard way of developing that consistency, but it's a great complement to the top-down approach that policy can drive at the same time.
I think it also speaks to what we're, saying when it comes to like utilities. Like, yes, utilities need to do investments in pilots, projects, and new technologies for sure. But also, who are the first movers in that? And like we heard Aaron Johnson say earlier that like PG&E now holds a conference where they have other utilities come and ask them, what are you using, what are you experimenting with, and what's working? But like the burden for that to fall on just a handful of like larger utilities. And then there's also so many smaller utilities all around the country that just don't have the ability to do that. Like the federal government is essentially subsidizing that research and that development on behalf of like the broader industry, which is good. It also means we might get more standardization, to Brian's point about like why, we should be speaking a similar language. We should be doing, should be testing in similar environments. We should be able to do better comparisons between these new technologies as well. And so I think all of this goes towards being able to support that. I think access to more like testing research centers, testing protocols, and being able to do more like comparisons between the technologies would also be really interesting there as well.
And thank you, Julia. Don't ask me to explain what SPARK stands for. We're getting close to audience questions. I have one question on my end for you, which is, I think you started to get into this earlier, but how is the conversation around data center load growth, which I love that this hasn't just been monopolized by the data center conversation, but how is the conversation around AI load growth and affordability in certain parts of the country changing the landscape for these technologies?
You're welcome.
I was looking around for aren't we supposed to have tequila shots whenever anybody says data center load growth?
You get it after you answer the question.
I mean, we did touch upon how this is such a major driver for national priorities and how now we're seeing DOE investing because it means speed to power, and we need to put everything on the table and be developing everything we can. I will say on the distribution side of things, I get involved in large load tariffs, large load applications for service in jurisdictions across the West. And pretty much every one of them is asking, how can we fund distributed resources, aggregated DERs, VPPs, as an offset to the capacity that we need and the flexibility that we want to show. It's not just the total capacity, it's also that flexibility between 5 and 9 in August evenings or 8 a.m. on a January morning. And so they are a driver of development, not only of the actual resources, batteries in people's garages and smart thermostats on their walls, but also the aggregators and the communications and even the DERMS technology, because the utility, so a large load customer comes to a utility and says, we want to develop here. One of the things we'd like to offset our capacity is with a VPP, and the utility says, how do we operate that? And the large load customer can help to fund either the ADMS that talks to aggregators, or an aggregator DERMS or a DERMS system. They can contribute to that system, and they can also bring on the distributed resources themselves. So they are directly helping with that grid modernization. Do you want to talk to Getz?
Yeah, I think it's good news and bad news, and I gave PG&E a lot of flowers, but I'm gonna throw a little bit of shade now, because this is a problem that the renewable or any energy developer has been dealing with for a long time, that the investor-owned utility, when they figure out or decide how much it's going to cost to interconnect you have to pay for that infrastructure, and you usually pay their return on equity on that infrastructure as well. And it's like, is that a high-risk investment for the utility? No. Could you let the developer kind of pay the whole bill and put it all on them and not pay the ROE? Maybe you should. I think data center developers are asking for the same thing. They're saying, let me put my money towards this. Let me build the upgrades. And the utilities are saying, no, this is our stuff, and we're going to rate base it and make our profit. So that is a challenge for this technology, and I think some data centers are so eager to get it done. Google has kind of had an open season for reconductoring projects. They're like, we want to see reconductoring happen so badly that we will put our money into it, even if it doesn't even necessarily help us. We'll choose you first if it does help us, but we just want to see this happen. And that's the level of interest that these hyperscalers have in speed to power. And then that's the really good news for Getz, is that there's nothing speedier than getting more out of what you already have. And so if you're really on that 2-3 year timeline, there's no transmission infrastructure and only some generation infrastructure that can come online in that time. So you have to modernize and innovate to get that extra capacity. Grid max, hashtag grid maxing, actually coined by Anna over here.
I'll just echo what everybody else is saying. It's really, you have another funding partner at the table, and another group that's putting advocacy towards some of these projects, strategically sometimes and sometimes not, but either way the pressure's there, and that trickles downstream too. So like even when you're fundraising, for example, like it's way like climate investing is, depends on what space you're in. But right now, energy is definitely having a moment, and like the funding looks good for early seed stage companies like us, and like a lot of people that I speak with. And so that that's buoyed and bolstered really by what people are seeing as the growth in the industry. And so there's another way of kind of getting access to those resources.
Great, well, thank you all so much. Let's turn to audience questions. We've got about 10 minutes, I think, if we've done our math correctly.
Check.
Check. Thank you. Are you familiar with the bill SB 905 by Weiner? And the question is, does it make sense to reduce customers' electrical bills by removing the regressive, the money that is put away for wildfires and underground cables, and move that to a general fund rather than using that to charge customers? That's what SB 905 is all about. Does that make any sense to you?
I don't know that any of us are quite in that level of rate design, but there is stuff in your bill that could be somewhere else. So rates are such a complicated thing and go through a ton of oversight and fiddling regularly. So I'll leave it there. The wildfire question is a big one.
I'll just, again, no direct insight or solutions, but I would say adding in insurance into that is another key thing as well, especially when you look at the wildfire factor. It's like, where do those costs go? And then when you think about, from a utility, making a decision about, do I underground a line? Do I use technology to get more information about how do I monitor and run that line safely? Very, very different decisions in terms of CapEx, but all like initial investment, but then also like how do you think about that from the insurance component? And when it becomes harder and harder to get like insurance coverage, how do you think about the financial implications of that as well?
Thanks, guys. Other audience questions? Anyone? Yes, some grid maxing questions in the back. Excuse me.
Thanks. Oh, it's loud, sorry. I'm Katrina. I'm curious, you guys talked about performance incentives and a little bit on the UK. I'm curious if you can speak to that and see what's your bet on what the most viable path forward in the US for that to happen.
Okay, do you want to go or should I go? Okay, well, the WAT Coalition really started in around 2017, and actually going all the way back to 2005, Congress passed a law that said you will incentivize grid efficiency and advanced transmission technologies. And FERC said, okay, utilities, you can come to us and propose an incentive. And I don't think that has happened yet. But, they basically said, like, if you can justify why this is riskier and deserves higher level of compensation, we'll consider it. We went in and said, that's not really full implementation of this law. My boss, I wasn't working with Watt at the time, but they looked at that UK example and said, can we do a more limited version of this, where you just get to, if you're the utility and you can get lower energy costs by using GETS, you can keep half of the energy savings, not the infrastructure savings. That's the hundreds of millions of dollars. The energy savings is in the tens of millions of dollars. Still meaningful. So proposed that at FERC, and they vetted the heck out of it and just couldn't pull the trigger on changing it. And I think part of that is it's with performance-based rate making, it's so hard to know what is enough to get the utility to change without overpaying for that change. Like in Hawaii, one state where they've actually implemented some performance-based rate making, I know one kind of success story was in, I think, DER interconnection, speeding up the timeline. The utility was part of what was slowing that down. And they said, okay, if you can hit this metric, you'll get this reward. And I think they immediately hit the metric. So I was like, okay, did we set the metric in the right place? What I've heard about that policy is it actually then showed the other slow parts of the process and made more homework. But I think that there's other PBR that then kind of didn't go anywhere, like this FERC order. You put it out there and the utilities say, we're good with the CapEx model. Let's not rock the boat. Let's not accept a small change even, because what comes after a small change? Potentially a bigger change. So that's the state of PBR in the US as I understand.
I have two responses to basically along the same lines about how can we take little pieces of the experience from the UK and implement it here, not the full-blown model. I'll say I'm a bit of a PBR skeptic, though I had economics training and a good economist should love PBR, but in reality, it's very difficult to design. And California in particular, we've had a bit of a hangover about previous PBR that hasn't gone well. So the things that I think can be implemented from the UK model, one, flexibility first. And the way you can do that is through distribution system planning. If there were a best practice that I were to recommend nationwide, or at least to increase nationwide, would be distribution system planning with at least a 5-year horizon that looks at where you expect electricity demand to grow, builds the most efficient system there, and you can do flexibility first. And you can have commissions and other stakeholders reviewing what the utilities say they want to build. Did you consider non-wires alternatives, or just a VPP program, or just a TOU program, time of use rate program, to get the flexibility out of the system before you propose the lines and wires. The other variation that I'll talk about is platforms. The UK uses a flexibility platform that says where are the grid constraints, what are the DERs available to address it, and they can bid in. It's a market. It's like what the California ISO runs for the wholesale market, only at the distribution level. We're not going to get that here anytime soon, but we can have more public data platforms, customer use energy data, the DER registry of where the DERs are, what their capability is, and then something that provides some transparency into what the distribution constraints are. Building on hosting capacity analysis, which we've already got. Those 3 platforms bring a lot of transparency, and this is the key, transparency for solution providers and customers to say, I can meet that. I can put together a VPP, a aggregation of DERs to meet this grid constraint here. And so you're unlocking the vibrancy of the market to bring its solutions to the constraints through the power of data.
Thank you. Julia, you've mentioned reconductoring a few times. And for those who are not familiar with it, one of the things that's essential to it is strengthening the transmission lines so that they are capable of carrying more current, adding more conductive aluminum to that line. Well, we talk about bottlenecks often in this community. Here's a bottleneck. That is the supply of carbon fiber necessary to run those new lines. Do you, sorry if this is really getting in too deeply in the weeds, but do you have any familiarity with whether that bottleneck has been well addressed yet? Because I know a lot about that market, and there is not enough carbon fiber in existence to do this.
I think that's one gripe I have with a lot of studies about reconductoring, is they say, oh, well, we can reconductor 80% of the grid or something like that. It's like you can't reconductor 80% of the grid, not just because you don't have enough carbon fiber, but because you can't take lines out of service and like schedule outages and have your crews out there. There's lots of reasons why that's going to be a slower process than it seems like on paper. But my understanding is the US market for the carbon core conductors is 10% of the global market right now. So I think there's a lot of room for growth. Whether that, like what shape that growth takes and whether supply chain is part of the constraint, I don't know when that becomes an issue, but I think right now demand is the issue and that there's not. Okay, yeah, well, I do know that lead times for high performance conductors can be longer than you expect, so maybe that's part of the issue.
One more question? Let me see. Oh.
Oh, sorry. Okay. Excuse me, sorry.
I'm wondering if we could address kind of what does municipalization look like? And I know clean power, SF, obviously. And also, in that case, what do stranded assets look like for ratepayers that aren't in an area that would be municipalized?
The only observation I have is that publicly owned power seems to be able to move a lot faster in a lot of cases, and is one of our. We talked about the case studies. Many of our best case studies come from co-ops that can adopt these technologies because they've only got one board of directors to present it to. It's a lot more direct line of decision making.
Oh, yeah.
Julia, you mentioned the utilities want to rate base these GETs and these advanced conductors, and that means as ratepayers, we end up having to pay the 10-year, 20-year, 10% extra on it, and makes it very expensive. What are some alternative structures you would propose? Yeah.
Ooh, yep, we're live. So I think for grid enhancing technologies, because they're 2,200 times cheaper than traditional infrastructure, that's one of the wins. You don't have to worry as much about who's paying for it because it's a drop in the bucket, not a whole new bucket. So that's easier for GETs and even reconductoring because you're potentially not investing as much in new towers or what have you. However, some of the models that do exist, I think even in the States, in the Southwest Power Pool, there's certain upgrades that can be sponsored upgrades where the grid user pays for the upgrade. I think I was in an SPP stakeholder meeting where that was proposed for dynamic line ratings, and the utilities were having none of it. They're like, well, it's going to go on my line. What about the software subscription? Yada, yada. So they still have to say yes, essentially. Like the utilities own the grid. And so, the cost of service is the way that that their business model is built on. So, yeah, that's all I have.